Next, I want to briefly talk about the cyber defense approaches. So in our previous work, we briefly divided the defense approaches in the following category. The first one is security measurement sensors. This can incorporate tamper-resistant hardware to prevent unauthorized access, end-to-end encryption to protect data transmission, or data integrity measures like digital signature and hash function to ensure the authentication and prevent manipulation. The second one is basically maybe focus and later on is that data-driven machine learning approach, which is popular defense strategy. As we know that power system is not under attack most of the time. So there are massive amount of normal data for the machine learning algorithm to sufficiently learn. In addition, the construction of data-driven approach does not depend on the network topology for the power system. And also this approach is sensitive to the time variant measurements, which can be very effectively in detecting the FDI attacks created by the spatial relationship of power system. The next one, which is research focusing on previous work, is moving target defense. Moving target defense is an emerging concept which are widely used in traditional IT system. I will get into that in the next slide. And also the watermarking is another approach. Watermarking is to inject unknown noises as a probe input to the system, and expected effect of such input should be found in the true measurement output due to the system dynamics. So watermarking can provide authentication and is effective against physical attacks or insider attacks who are usually have authenticated users. The next one, hybrid approach. They usually basically form the defense in depth approaches by combining different approaches over there. The two-layer model in the right finger is a graphic form of the smart grid model to summarize the defense and mechanism.